3D printing versus traditional manufacturing. 3D printing and conventional machining are often compared, especially in CNC machining and plastic molding. Engineers always consider many aspects, such as cost, lead time, capabilities, etc. Traditional methods are reliable, versatile, and suitable for mass production. The 3D printing process is fast and grants engineers some design freedom. It should be mentioned that 3D printing technology is additive manufacturing in contrast to traditional manufacturing processes, subtractive ones. Let's find out which production process suits your purposes better overall. Comparing traditional manufacturing versus 3D printing. Traditional manufacturing technology and production with 3D printers can be matched in several ways. Here are some comparison factors valid for both methods and a detailed explanation. Simplicity and convenience. CNC machining. It's a labor-intensive process that also requires highly specialized personnel. For one, it involves a designer of 3D models and a programmer of CAM files. It also requires engineers that would adjust the settings of a CNC unit, such as tooling, rotation speeds, feed rates, cutting paths, and more. That's before the process even begins. Traditional manufacturing methods also require the constant presence of a skilled operator since some failures on the production line are frequent. Not to mention post-processing steps for every machined component to undergo. 3D printing. In its turn, additive manufacturing is a less labor-intensive process. It does not even require that highly skilled labor. Only a designer/engineer to prepare a CAD file, and you may proceed with printing right away. 3D printing can support with many types of material. You can print with plastic, metal powder and PCB prototype. Of course, you will still have to adjust some parameters such as orientation, fill, support structures, etc. But, to be honest, every office member can be trained to use even an industrial-level printer. Supervision is not as necessary as with CNC machining as well. You may even set some additive processes on a remote, fully automated control. Take a look at what additive manufacturing may look like in the image below. Accuracy and geometric complexity. CNC machining. What's good about traditional methods is that they can achieve extreme accuracy. But it's not always achievable because of the chatter, tooling in use, material, etc. There are also some design constraints related to tool access, holds, square corner geometry, and more. Take it as the fact that CNC machining is not as versatile as an additive process. 3D printing. Many engineers opt for additive manufacturing because of its wide design capabilities. Industrial printers can create parts with geometries that CNC units just cannot replicate. Additive manufacturing cannot compete with traditional machining in terms of accuracy in the present day. Constraints are printing methods, filaments in use, etc. The method is precise enough to suit most purposes. Cost effectiveness. CNC machining. The traditional process requires much prior preparation. It includes investments in tooling, CNC units, raw materials, programming, designing, machine setting, etc. Besides, subtractive machining produced a significant amount of waste. Some of it can be reused, and some are just disposed of. However, large batches of products can be produced at reduced costs with CNC machining. It's because some types of expenditures involved in the process are constant. 3D printing. Initial investments in 3D printing are much lower. After all, only an industrial printer, some designs, and filaments are required. It results in lower cost per part produced. 3D printing is a more economical way for rapid prototyping exactly for the mentioned reason. Yet, for large-scale production, this method brings no cost-effective benefits. Sustainability. CNC machining. The working principle of traditional machining is just cutting the material away from a workpiece. It always results in huge material waste. Its volume only increases in post-processing steps. Besides, CNC units use coolant in the process to lower the temperature of tooling and the material surface. It also negatively affects the overall sustainability of the process. 3D printing. The material is fed to the machine directly, and almost all are deposited onto the work table. That's why 3D printers do not produce much waste. Besides, some manufacturers tend to optimize their workflow. They do it by minimizing support structures, reusing the resin, reclaiming detergents, etc. Post-processing. CNC machining. With traditional methods, some surface finishing is due. Coatings, painting, or sandblasting are also applied frequently. CNC machining has a vast number of post-process options to apply, which is a positive factor. 3D printing. Here post-processing may include treating with UV light, removal of support structures, sanding, painting, etc. Basically, the most depend on the process and filament chosen. And here is a comparative overview in which you will see a technical difference between a subtractive and an additive manufacturing process. Comparison criteria. CNC machining. 3D printing. Turnaround time. Extensive time is required to analyze technical requirements. Setup choosing, and programming also take much time. Once done, the process can be automated. The manufacturing rate is high. Do not require much preparation overall. The manufacturing rate is mediocre and heavily depends on the method, filament, machine, etc. Variety of materials. A wide variety of metals, plastics, polymers, wood, composites, foams, resins, and some elastic materials. A limited range of metals, plastics, resins, and biocompatible materials. Accuracy. Highest possible accuracy. High accuracy. Cost. Per unit cost lowers with the number of components made. Per unit cost remains mostly consistent regardless of the number of components made. Material waste. A lot of waste, sometimes can be reused. Very little waste. Labor expertise. The highest expertise is required. Less skilled labor is required. Goal. Mass production. Mass customization. A number of steps to get the final shape. Usually, more than one. Usually one. Summary. Subtractive and additive machining are two primary options for manufacturers. The first ensures low-cost mass production but requires some high investment and overhead costs. The latter is better for rapid machining overall. It does not require a high investment cost, nor does it demand expertise from labor. You may be recommended to evaluate the desired workflow. If it's one-off prototyping or high-mix but low-volume production, 3D printing must be your choice. For any other situations, CNC machining is the only way to go. Company name, Shenzhen Banshun PCB Company.com Limited. Company, Room 316, Number 1, Nanbo Avenue, Tengwei Community, Fuhai. Address. Street, Baoan District, Shenzhen, China. Phone, +86 147 3743 9020.